understand the following for the lecture test number 4. So let's go ahead and explain it. So the first thing that it says here, we're looking at the page that has steps 1 through 7. Steps 1 through 7. All right? Number 1, it says there to pick a partner. All right? So you need to do this with a partner. And you're going to be doing this assignment before the break. Yeah. So that means that before November, the week of November that we're going to be off, so that means that the due date for step number 7, the due date for approval, for you to get it approved, is on the 12th for approval. What is it that I need to approve? Your scientific article. That's what we're going to be discussing. So what you need to do is go to the library, that's the easiest thing, and identify a scientific article that you're going to end up explaining to the class. All right, that is your grade. The scientific article is based on anything that has to do with humans. I want to do it on marijuana. As long as the human component is in there, you can do it. All right, I want to do it on cancer. As long as you find the article, you can do it. So you got to find the scientific article, and you're going to end up putting it together by the slides that are here. Again, I gave you a description of step number 5. What are the slides? So again, step number 1, identify the partner. You need a partner. There's a cap on the number of people that can do it individually. All right? There's a low number, only three people. If you don't have the opportunity to meet with somebody, you better be the first to tell me. All right? So that way you don't end up having that problem. Anyway, so I want you to look at get a partner. You could go up to 3 people in a group, no more than 3, not 4. 3 is the max. 2 is what I want, the ideal. And what you're going to do is select the article, present it to me. You don't need to finish it. You just need to grab the paper so that I can approve it. So that you could start presenting by Friday, okay, or Monday. We're going to be doing those days, Friday or Monday. So if you're ready to present, we're going to be presenting on Friday or Monday. Okay? So who's going to present on Friday? The persons that are last on presenting on that day. This is where I'm going to apply the rule from the Bible. The last will be first. So anyways, if you wait to turn it in on Monday, that means that you're going to go on Friday. And we're going to have this Friday for you. The reason why I have to do it is because if we leave it for Monday, we're not going to be done. It's only 4 people per hour. Well, 4 groups, because it's 15 minutes. All right? So again, please do not wait. You have a month more or less, okay? So that you could be ready. If you want to present already next week, let me know. Not on Monday, but let me know. After Monday. You can start presenting if you want. So again, we're heading for this day that you're presenting. If you're the last one, you're going to be 4 groups that are going to be presenting on that Friday. So don't be those 4 groups, right? If you want to be one of those 4 groups, present this last. You present it on that day. Okay, so for approval is on that day. That's it. If you don't show it to me, you cannot present on Friday. You will not be able to present on Monday either. All right? We'll have volunteers also. Again, if you want to go on Friday, it's only 4 slots that are going to be open. We'll keep them open. All right? If you want to continue present, we could also do it on Friday afternoon. But this is for Friday morning at 11. Only 4 groups are going to go. That's what I have scheduled. And these 4 are going to be the 4 last ones that turn it in. All right? And of course, the rest of you will go on Monday. Unless you don't want to, we could use the afternoon to continue with the presentations. All right, if you don't want to go on Monday. The reason why is because I know I'm not going to see you on Monday. Some of you are going to be gone. Because you have your kids and all that. See, because they have a whole week off. We don't. We're still going to have a class on Monday, and we're still going to have class on Wednesday. But it all depends. If I see everybody's not showing up on Wednesday, then I won't make it up. I'm going to have to just continue on the following week. But anyways, usually that's the problem that I always have. People don't show up. All right, but we're trying to make sure and head up before that. So again, if you're interested on having a week off, just make sure you present. I'm not telling you could have it off. We're still going to have class, all right? So please make sure that you schedule appropriately. So I'm trying to make sure that you're aware of that. Anyways, so on step number 7, please put the due dates for approval is on the 12th, and the presentations are on the 16th and on the 19th. Okay, so that's when you need to have your PowerPoint, the whole thing, the whole shebang, ready. On this Monday, all you need to do is have the article. Okay, you're doing it on that, we'll make the PowerPoints on that. But again, don't wait. Because remember, the people that do it there, most likely you're going to be presenting. It's only 4 groups, the last 4 groups. All right, so when I approve your article, what you need to do, I'm going to keep record of that with a scratch sheet of paper. And what I mean a scratch sheet of paper is half a sheet of paper at least. Okay? Because last time, I'm afraid of saying that again, you know what people were doing? They were doing this. Scratch sheet of paper, they put their name and then they turn it in. All right, so no, I don't want, I'm sorry I have to be that descriptive to you. Don't do that. Again, have a sheet of paper at least. Some saying scratch sheet of paper, that's true. Anyways, but it was a hard time because I lost some of these, because they're too small. Anyways, don't make it too small. Anyways, grab your partner, all right? And the next thing you're going to do is follow the guidance. So what is a scientific article? That is step number 2 that you see there. So again, this is the scientific article right here. This is from the Journal of Virology. What does viruses have to do with us? Well, this is because of this paper that breast milk has the inactivating agents such as CD8 T cells that inactivate HIV. It's in breast milk. See that? So this paper basically is what gave support for not promoting any longer saying if I'm an HIV female, not to breastfeed your kid. It's going against that because that's what they were told back in the early 1990s. If you had HIV, don't breastfeed your kid because you have a 22% chance that he's going to get HIV. But the babies were not getting HIV that way. It was through a lesion on the nipple. So if there's a lesion on the nipple, opening or whatever, use the other one. You got to. So the point is, that's the idea behind this because breast milk is very effective. It does have that T cell. And you see here, the interesting thing about going to scientific papers, it gives you better information than what you are going to see in your books. Again, this is from 2002, and it's still not in the books. So that's the reason why you got to read up primary sources so you can see.
A lot of people still say today.
Yeah.
In fact, we were discussing that yesterday in another class, and one of the sources of HIV transmission is breast milk.
Yeah, which is incorrect. With this paper, bring you the information that no, it helps you to inactivate. So that again, you see the turnout, but it takes a long time. It's like saying Pluto is not a planet. What's up with that? I didn't think it's a planet. Anyways, you see how long it's going to take? Yeah. Or that we still have the 5 kingdoms. They're gone since 20 years ago. See? We have domains now. Yeah. Anyways, the point is that look at the scientific paper. It should have a title. It should have this. This is very important. Most of the articles, if you show them to me, and I don't see this right here, it hasn't been published. It could be placed on the internet, and we have a lot of people that place their own research, whatever, very simplistic. That's why people select them. I get it. It's simple to explain, but it hasn't been published. So make sure that you publish it. All right, so this one has the volume, the year, you see that, when it was approved. And then, of course, look at the introduction. Sometimes it doesn't have that label, but the beginning is the introduction. But this is the most important part right here, that it has materials and methods. That is the key for a primary source. If you don't see that, most likely it's not a primary source. It's secondary, tertiary. Somebody read it, and they're going to explain it to you. That's not what I want. That's a review paper. So I'm always going to go to the footers over here, all right, to the legends, to see, because sometimes they'll tell you it's a review paper. So no review papers, please. Again, you're selecting a primary source. So again, one of the key things is, make sure you circle it on your paper, step number 2. It should have materials and methods. Results, sometimes they should have the label, sometimes not. Again, you see it here as tables, diagrams, figures. As you go see, it has several figures in here, again, because of the experiment. Sometimes it'll say discussion, not necessarily, right? You don't need to see discussion, but sometimes they give you discussion, the label. Conclusion, sometimes you see it, sometimes you don't. But at the end, You see it has acknowledgement, thanking people that let their breast milk be analyzed, blah, blah, blah. See that, where it came from. Then of course the references here. So you know it's a scientific paper. It's based on previous other studies. So that's what a paper looks like. So what are you going to do? So you're going to get the paper and you're going to read it. Read it once. I still don't understand it, mister. You read it again. You still don't understand it, you read it again. If you still don't understand it, stop wasting your time. Get another paper. All right? So remember, you're going to be explaining this to us. You're going to be the expert. You could actually, say whatever, and we're going to buy it if you know what you're talking about. All right? Because you're the one who's seen the paper. We haven't. So we're going to try to understand it as you are presenting this. Anyway, so this is how you're going to put it together. It's step 5. You're going to, remember, do not go to the National Library, the NIH.gov. This is the largest medical library. It's good, but you have to be a member. It's going to cost you like $300 or something. So don't do that. Already the libraries have done that. UTEP's done that. NMSU library. We in our library here have not done that, but we do have a data bank, and some of those files are there. So it's better to go to the library to identify the paper more quickly. So that's the thing I want you to remember. It's better to do it that way than Googling it, or banging it, or binging it. It takes longer. So once you have time to find the paper, and step number 5, you're going to put it together. How are you going to put it together? In a PowerPoint. Okay, so in the PowerPoint, so basically, these are the 2 files you guys are going to be, giving me. You're going to provide me in a USB, and I'll give it back to you. I'm not going to keep them. Okay? So basically, you have like this, the PowerPoint and the PDF file, like that. That's all I want. All right? You turn it in, I give it back to you. Okay? So again, the PowerPoint, you got to put the title. So you put the title. You see that? And then the introduction. You got to put it in your own words. The title, the first page that you saw there, comes from the title in the journal. So don't change the title. Leave it like it is. I know sometimes it's very long. Just leave it. So that's one of the 3 things you could copy directly from the paper. The title. Copy it directly from the paper. All right? And then the introductions over here. This is basically the one you really have to read about so you can know the significance. And then, of course, put that in your own words. Do not copy and then paste it. All right? I've seen that a lot. Then in their introduction, they were, as we were up in the canopy, allowing the elephants to go by. You weren't out there. You weren't out there, yesterday. Anyways, so really, that's what happened once. It's a true story. Anyway, so I do read the stuff. So again, the point is, remember, you're going to be presenting it to us. So the first slide can be 1 or 2. Don't make it longer than that. The introduction. Just by reading it, you're going to summarize it. I stopped here because your 3rd slide or subsequent slide after the introduction, you have 15 minutes. Don't make them that long. You see, that's the whole point. Your 3rd slide or the slide after the introduction should be your objective statement. And the objective statement is right before the materials and methods. If that article doesn't say it right away, usually you're going to find it there on the last paragraph. So right here it tells you, our studies demonstrate. So that is the second thing. Second item, you could copy directly from the paper. And it's not copying the entire paragraph, just a sentence. Maybe it's 2 objectives, then 2 sentences. But you shouldn't copy the whole thing. And you're going to need to put them on the slide. So after the introduction, remember that now you're piecing together the paper. Again, the introduction, 1 or 2 slides, no more than that. Okay? So that's 2 slides, and then your objective. See that? That is copied directly from the paper. Remember, title, objective. All right, the next slide after that is the materials and methods. But let me show you the secret before you do this. This is how they did it. Before you start doing the materials and methods, I want you to do the following. I want you to go to the results of the paper. The results, and I'm saying singular, results, not results. So what you need to do before you talk to me about the materials and method, this is the best way to do it. You go to one of the results. Is this the best result to support the objective statement? Or that result? Or this? According to this group, it was this result right here. So this is the result I'm going to be placing after my materials and methods. So this is the result I would put in the materials and methods. Explaining, giving us information so that we can understand what's coming up on the result. So select the result, that supports the objective and then explain how they did that result. Does that make sense? So that's your hint. Select the result that supports the objective, then explain how they got the result. So on this paper, you saw that they had a selection of various ages of the females. Again, that could be important, but is it supporting the objectives that breast milk is inactivating HIV? And the answer, no. It's, it's a variable, it's good, but this is the result that is showing you that. Okay? And then go ahead and explain it. Give us enough information. You don't need to tell us how PCR works, because they use PCR to analyze the viral load. Again, if there was still some viruses left over, again, you got to do some reverse transcriptase RT-PCR for that to be analyzed. But you can simply say that the genetic material of the virus were analyzed after inactivation. Just simple as that. You don't need to go into detail unless it's necessary to understand this. See that? So the last thing that you could copy directly, again, is the title. Don't change it. Copy directly from the article. The objective statement and this. The graph or the picture you're gonna talk about as the result for the paper. You could copy it directly from the article. So that's what this group did, but they didn't do a good job. Look at it, what happened. Look at the result that they gave me. Look at the results in the paper. What are they missing?
The legend in the bottom.
Let's see the bottom. You see that? I don't know what these bars are. So please don't do that mistake. Okay? So make sure you copy it correctly. Yes, the legend is needed, so we can understand what's the black bar mean, what's the white bar. Alright? So copy it directly. So once again, on the PowerPoint, after you explain how they did it, again, give us the result. And then, of course, the result explanation. You're going to get it from the paper. Again, don't copy and paste it. Put in your own words. Discussion in your own words. Conclusion in your own words. All this is coming from the paper. So it's a research that has been published. Any questions there? The last slide, you're going to put the article in scientific notation. As you can see here, that is in the correct reference, not in scientific notation, but in a AP style. This is not APA style. It's wrong. It should have been, because they gave me the PDF file. The file is PDF, is a digital file. They did not go physically to the library to check out the journal. See that? I know that because if not, they would have scanned it. They would have scanned it, given pictures. So I know that they got it from the internet. They're missing retrieve from and the date. That's the website. That's what's missing there. So this is MLA. That is correct for MLA, but I want APA since you got it from the internet, right? Or the source, wherever you got it. It's a digital. Anyway, so that is the idea behind this. Questions? So you're putting the article that you're presenting to me in scientific notation. So that means you go to the beginning of the article. You see that right here? See that? The title, the people right here, the authors. See that? That's where you're putting. You're not doing this. You're not putting these references in APA style. Does that make sense? That's not what I'm asking. I'm asking for the article you're presenting. So you go to the beginning right here, the beginning part, right there. That's what you need to do. Okay? And it's just one slide. So once again, for approval, our due date is for approval? Yeah, November the 12th. Remember, and on the 19th, we're presenting, only 4 groups are presenting. The next are presenting on Monday, the 19th. All right?
About the 16th.
You could also present. Okay? The 16th, yes, there's only 4, and then the 19th, we don't have that. All right. So that is the scientific article. I'm going to continue on with the sliding filament theory. Yeah. For which one? The fibula and tibia. Yeah, that was the right one. Yeah, it should have been the right one. Yeah, if it's wrong, if I put wrong for that one, yeah, try to. It should have been right down there. That's the only one was right. The other ones were left. All right, so remember the sliding filament theory, and we could do that towards the end. Okay. So remember that we left off with this right here. Remember? Remember? No? Did we get to this point of putting the sliding theory together? Well, let's do it then. Did we talk about this right here? Yes or no? Yeah, yes. I think we did. We got there. Yeah. So basically, the sliding filament theory with, because I showed you this video, okay? The video that was explaining to us how this propagation occurs. So remember, it is looking at the sarcomere. What we're trying to do is put this whole essay together. And remember what I said about this essay? It's worth more than 10 points. Okay? It could be just 10 points, but if you want extra points, that's where it comes from. From you adding on to the essay. So let's look at a small review here.
The formation of a cross bridge is initiated when calcium ions, released from the sarcoplasmic reticulum, bind to troponin. This binding causes troponin to change shape. Tropomyosin moves away from the myosin-binding sites on actin, allowing the myosin head to bind actin and form a cross bridge. Also note that the myosin head must be activated before a cross-bridge cycle can begin. This occurs when ATP binds to the myosin head and is hydrolyzed to ADP and inorganic phosphate. The energy liberated from the hydrolysis of ATP activates the myosin head, forcing it into the cocked position. A cross-bridge cycle may be divided into 4 steps. Step 1, cross-bridge formation. The activated myosin head binds to actin, forming a cross-bridge. Inorganic phosphate is released, and the bond between myosin and actin becomes stronger. Step 2, the power stroke. ADP is released, and the activated myosin head pivots, sliding the thin myofilament toward the center of the sarcomere. Step 3, cross-bridge detachment. When another ATP binds to the myosin head, the link between the myosin head and actin weakens, and the myosin head detaches. Step 4, reactivation of the myosin head. ATP is hydrolyzed to ADP and inorganic phosphate. The energy released during hydrolysis reactivates the myosin head, returning it to the cocked position. As long as the binding sites on actin remain exposed, the cross-bridge cycle will repeat. And as the cycle repeats, the thin myofilaments are pulled toward each other and the sarcomere shortens.
All right, so remember that what we had here was looking at the actin. Remember, the actin is 2 ropes, like a pearl necklace, right? And you see that it has 3 main components. The protein is, the purple one, the actin, and then we have troponin and tropomyosin. So remember, for you to get a contraction, you need to expose that active site on actin by removing tropomyosin. The only way to do that is for troponin to bind calcium. Where did calcium come from? From the membrane that's housing that calcium. So that is the SR. Now, I guess we have to go back and do the whole thing. Yes, so, okay. No problema. We could do the whole thing again.
So the essay is going to be on the entire
sliding filament theory. Yeah. All right, so let's go ahead and talk about it, because it looks like, I don't know, something happened. All right, so once again, let's start with the levels. Let's start again from the beginning. What the heck?
Well, now we're talking.
Let's go again from the levels of the muscle. This is not the essay, we're getting there, right? But we know that the muscle is composed of smaller units. The entire muscle is bundled within smaller units. So these are different levels. In the level 1, it's the entire muscle. And what is a muscle composed of, an entire muscle? It is composed of an outer membrane. That is the epimysium that I was telling you that you need to tear into the muscle so you can see the separation of the muscle, the epimysium. So that entire muscle has this membrane, the epimysium, and it's composed of fascicles. Level 2. So the fascicles, they themselves are bundles of these fibers, of muscle fibers. So the fascicle has also a membrane, perimysium. So within the level 1 and level 2, this is where we see the nerve. Nerve and blood vessels can reach at the entire muscle and also to this level, at the fascicles. So this is where I told you that a nerve doesn't necessarily need to attach or have contact with all the muscle fibers. It just needs to do it to one. And when this single one gets the signal from the nerve to contract, it will cause the neighboring ones to also contract. This is the all or none principle. One goes and then all of them go, if the signal is strong enough. So the innervation of the nerve occurs at this level, the muscle fascicle. Now this muscle fascicle is composed itself from muscle fibers. So the fascicles here are bundled together in groups of 10, and these groups of 10, you see it right there, as this fascicle, groups of 10, combined with 10 more packs. See that? They're all packed together. But when you look at the individual fascicles, they're composed of muscle fibers, and these muscle fibers themselves are composed of myofibrils. These are the hundreds of them that you see there. But at this muscle fiber, you have the endomysium, the membrane that surrounds the muscle, the skeletal muscle. And this membrane is the one that has a sarcolemma. Again, that is a membrane that we're going to be talking about. And this muscle fiber, remember, it's long. It's very different from a eukaryotic cell. It looks like a worm. Remember, that's what we saw before. It's like this. See that? It's a muscle fiber. It's long. It's not circular. So again, this is long. And then this itself is composed of these myofibrils, level 4. And this is where you have the blue membrane, as it's illustrated here. That basically is depicting the membrane that houses the calcium, the sarcoplasmic reticulum, or SR for short. So the SR houses calcium. And then the myofibril is composed by these building blocks called the sarcomeres. Sarcomeres come together and they make the myofibril. Myofibril come together in hundreds to make the muscle fiber. The muscle fiber group together with tens of muscle fibers and you get a fascicle. The fascicle groups with tens of other more fascicles and you get the entire muscle. See how it's one after the other? So when we look at the sliding filament theory, we have to focus at this level, at the sarcomere, because this is where we have the protein actin, the red, and myosin, the blue. So this is the building block where the contraction that we're interested on. How the contraction takes place. What are the interactions that are occurring? That's what the video that you just saw. So what is here? What is making up the sarcomere? The thin and thick filament, the actin and myosin. So the myosin, let's look at that. The myosin is the thick filament. That's the myosin. And the myosin has a tail, a neck, and a head, like a golf club, versus the actin, like a pearl necklace. So we look at the myosin, again, this one's composed of thousands and thousands of these, you see that? That make a myosin. That protein is composed of them. So what's unique is this head that is able to hinge, raise up, and attach cross-bridge to the actin. It's able to do that. Okay, so that's something unique about that. That's the thick filament. And the thin filament is the one that has this active site, but it also has troponin and tropomyosin. So what happens here is that troponin will change shape if it binds with calcium. So if it binds to calcium, it will change, conformation will change, and that will open up the active site on tropomyosin. So it will open it up, exposing the active site. But only if calcium binds to troponin. So that's where it goes. So we saw the essay with the following. Remember? The following. And this is what I gave you. That you have the SR, that membrane. That is the one responsible for releasing calcium. But when will it do that? That's what we're going to be discussing further. When the signal coming from the nerve to the muscle, that's what we call the stimulus action potential, is going to go through the network of the membrane called T tubules, so you could bring it to the SR. And then the SR then releases the calcium. Calcium then is going to bind to troponin. Troponin then is going to move tropomyosin to expose the active site on actin. And then once you expose that active site, myosin will hinge, bind, cross-bridge, and contact the actin. So it's going to be in contact with it, and then it's going to pull it towards the M line. And that's going to end up eliminating the A zone and the I band. So remember that in the sarcomere, we go back, when you contract it, well, this picture basically, you see how it's separate, and then it's going to come back together. So you have several bands that you're going to end up eliminating, shortening it. So you're going to cross them over. See that? Cross them over. So that is the shortening of the sarcomere, which is then going to end up detaching, so you can only relax or disconnect the contact of the myosin with the actin with ATP. Unlock it. Put it open. See that? You pump back the calcium, and the sarcomere goes back to its natural state. That's what we learned. So what we're trying to do is, this is your essay, but we're trying to add on to it. What we're going to add is from the nerve. See, the nerve contact with the muscle. Where is this occurring? This is actually going to be a specific site on the membrane of the muscle called the neuromuscular junction. So how did the signal from the nerve got passed down to the membrane of the muscle? And we have to understand what the membrane of the muscle has. These are basically proteins. This is what you see here. Proteins are involved, but these proteins are very unique. So a typical, again, membrane has these proteins. These are the proteins we're going to be discussing further next time. The ligand-gated channels, voltage-gated channels. So these are the main ones. The ligand-gated channels are going to be the first ones to receive the signal from the nerve. They're the first one. And they're going to be able to give that signal, that action potential, the stimulus is called an action potential, to the voltage. So it goes first receiving it, and then spreading the signal all over the muscle fiber through voltage-regulated channels so that it could reach the SR. So we're looking at how you pass the signal through the membrane. So what's unique is that the membrane has these particular voltage-regulated channels in the membrane of the muscle. So the muscle membrane is usually going to be negative. And that's basically what you're going to see here. Usually the membrane is negative. Why is it negative? To receive the signal, these cells constantly are going to be pumping positive ions out, negative ions stay in at rest. And the membrane is negative. Why is the membrane negative? And it's because it's using these channels to make sure it have, these protein channels, to make sure it has that negative charge of ions inside and positive ions outside. So the membrane of the muscle and the nerve is going to be the same way by using these protein channels. And this is basically a simple channel that allows for the stability of these ions. Now, the other reason why this membrane is going to be negative is because it has a phosphate. That's the description there. So the phosphate is basically this. glycerol. It's the glycerol head, and it has a phosphate. So that's why the membranes in your body are going to be negative. See that? Because it has the phosphate that is negative. These are hydrogens around. And it should be 16. I'm not going to draw 16, okay? 16 of these length of this. So this is what we call the fatty acid. So the membrane in these tissue, in the muscle tissue and in the nerve, they have that type of phospholipid. So all the phospholipids have a negative charge because of the phosphate and because you have these proteins that are making sure you have a negative ion, anions and cations. So when you take an electrode and you put it into the muscle, you're going to get minus 80 millivolts. Automatically that should tell you that is a muscle. If you see this number, minus 70 millivolts, then that is nerve. Okay? So this is what they're measuring. The charges of those membranes that you have at the starting point. So to produce a signal through these membranes of the nerve and the skeletal muscle, you must have established these beginning concentrations of ions, anions, negative. If it's minus 90, it's going to be cardiac. This is skeletal. Okay? So anyways, so that is one of the uniqueness that we're going to be looking at. All right? With the video that's going to be explaining how you're going to end up producing this negative charge. So that you could activate these channels. So that you could send the signal. Remember, we're interested in explaining how the signal goes to the SR. How did the SR get the sign, hey, open up your gates? How did it get that? So that's what we're going to be explaining. The route of the path of the signal from the nerve to the muscle all the way to the SR. So that's the idea behind this, all right? So that way we could understand what's happening here. So this is basically the group of proteins that we're going to be hitting next time. Okay? These proteins that are in the membrane of the skeletal muscle. So that you can see how the signal is going to start off from the nerve, send it to the muscle, and in the muscle, how you're going to end up changing that charge of the membrane. It's like a wave passing through the entire membrane from negative to positive. This is a positive charge that is coming in. So we're going to be explaining that. All right? Okay, so it's going to look something like this. You see that? Muscle, the nerve, where the muscle meets. And we're going to talk about these channels. And then how you're going to end up passing it through the membrane to the sides. So this is where we could add on to the assay. How did the signal go from the nerve to the muscle, and then from here, these light gated channels, how are you going to send it to the membrane of the muscle, to the T-tubules, to the SR. This is what we call the action potential propagation. Okay? And it's dealing with voltage rated channels. All right, so next time we'll see that on Monday. Don't forget this afternoon, the lab is on your own. You should focus on page 196 and 197 of your exercise 13 to learn the overall muscles. If you see any discrepancies on the test, please make sure you talk to me right now so we can correct them. All right, we'll see you on Monday. Don't forget, corrections are due at the beginning of class on Monday. The corrections of this test too.